explained here. And there are a lot of challenges. About these challenges, I just point out the last point, transparency of the whole process. There's nothing surprising that some process is biased. The only real, let's say, policy, the good policy, should be transparencies, to be aware of what we are doing, to be aware if a system has a certain bias in its results. This is a set of a principle to address for AI ethics. There are different lists similar to this, but transparency and explainability is the key point. How to develop an ethically aligned intelligence system? It's not just talking. IEEE, you know, everybody knows IEEE, has developed a suite of standards specially designed for this. IEEE 7000 series is modeling processes for addressing ethical concern during system design. There are a lot of, and these are all recent initiatives. Yeah, you can see this was released in 2020, 2021, 2022, and some of them have been planned and not released yet. I'm not spending a lot of word on this, just to point out what does it mean, ethics for innovative research, like researchers who work in AI or use AI as a tool. Currently, if you consider this issue, you are a first mover, and this represents an enormous potential. And soon, it will probably, to be ethically conscious, will represent a requirement, an obligation, a compliance, especially for public organization, application on government. They should not discriminate certain categories, etc. So these are some of the many examples. In the meantime, there is a growing number of regulation. I just mentioned the two most recent, this Artificial Intelligence Act that was first presented by the European Union in 2021, and the Algorithmic Accountability Act of 2022, so really recent in the United States, where they provide provide the guidelines for documenting and assess impact of decision system. So I conclude to say that ethics in AI, what we start even to propose and discuss with our workshop, is not only one thing that is good from a moral viewpoint, but it's just to be comprehensive in analysis of a system, of all the consequences, the societal consequences of our system, and basically to be aware. You can even have a bias, but you should be aware of the bias. This is the message, okay, that we like. And the key word is transparency. You have most of these biases are embedded, are implicit. We work to make that explicit. And I will mention this also during my presentation later. Okay, I took your time. I will give back the time during the presentation, and I'm glad to introduce the first speaker of the workshop, which is Gulmira. Please. Yes.
Can I?
Yeah, you can sit.
Sorry.
Yes.
I have a question.
Okay. Sorry.
Just because one of my professors was most interested in the crossing between artificial intelligence and planning.
And planning, yes.
Digital planning, assessment, and so on. And he tried to think about something that was coming from the reference prediction, the not shown. A lot of kind of ethics. Okay.
Yes.
So this is obviously ethics has definitely a lot of interpretation, but also the quantity. because the behavioral contexts are infinite in some way. So maybe this discussion, I think that can have the potential to increase the arena.
Yeah, of course.
In a period in which this is very important because of the internet, of the network, and so on. Okay. You have some the idea about this connection when different point or certain point?
Okay, I will. Okay, I didn't expect at this moment to have the discussion, but I just answer you quickly that what is in general what is needed for this issue is to consider a multidisciplinary approach, even to have even people from the area of social science, of psychology, and so on. Because I mean, like a computer scientist or informatics, we are not aware sometimes of some bias or some discrimination that you can do. And this input can only come from expert of the field that we are addressing. So for me, for instance, a classification problem and only some parameters to be considered good or bad, but the input can add societal impact parameters of this kind that we can measure. Okay, thank you. It's my pleasure to introduce Gulmira Bekmanova, which is going to present the linguistic foundations of low resources languages for business instances in Kazakh. Please, we will take the share.
Thank you, Feda. Good afternoon for everyone. Linguistic foundation of low resources languages for speech synthesis on the example of the Kazakh language. My name is Gulmira Bekmanova, and I am, and my colleagues, you can see them on the slide. We are from Eurasian National University, Nur-Sultan, Kazakhstan, and I am very happy to be here in presence because last 2 years we took part online, so it's honor for me to be here, and let me start. So this research or this work is carried out within the framework of the project development of scientific and linguistic foundations and IT resources to expand the functions and improve the culture of the Kazakh language. This project financed from the government of Kazakhstan Republic, and the main reason why they financed such kind of projects that because a long period of time in the past we were in the part of the Soviet Union, and the Kazakh language is not so important, wasn't so important, and we didn't have so much so deep resources for IT resources, I mean for Kazakh language. And nowadays, of course, we want to develop our IT resources in our republic, so that's why the Ministry of Education financed this kind of projects, and we have different tasks, and one of them is development of the speech synthesis in Kazakh, and this project started in April only this year, so we started from the foundation, and I had some background. I did my PhD thesis on speech recognition in Kazakh language. Then I did once the transcriptor, of course, for speech recognition system. And now we try to prepare a transcriptor for speech synthesis. So these linguistic foundations of the synthesis of Kazakh speech based on Ahmet Baytursunulu works, as well as some ethical aspects of the perception of his scientific and cultural heritage. I should explain that Ahmet Baytursunov was outstanding Kazakh scientist. He lives a long period ago. He was philologist, publicist, multifaceted scientist, and his life was tragically cut short due to his patriotic and political activities. So and difficult to choose the type of his activities that made the greatest contribution to scientific and social political life. But I, based on his philologist work, which were made more than 100 years ago, 110 years ago. And later we had a lot of different researches about philology, I mean the phonetics of the Kazakh language, but in like topic of this session, I can say that he was killed by the government before, but his research is the more still the more modern and more close to real speech synthesis and speech recognition of Kazakh language. That means that that he did them without any, of course, computer processing before, but he had very correct results, like when he shown first time the system of sounds of Kazakh language. So the Kazakh speech synthesis system is not fundamentally different from any other speech synthesis system. I think that you have some knowledge about them, that it's like the other system for every language. But of course, when we talk about the speech synthesis, we talk about some alphabet, sounds, and so on. So when the first or main important things for the speech synthesis system is transcriptor. This, no, I can send the program which made transcription, which make the transcription of words like they sounds, and that's all. So we need, for speech recognition, we need some simple transcription, but for speech synthesis, we need more powerful transcription with all sounds which we have. And the first thing what we need to do, we need to minimizing the size of the phonetic alphabet without compromising the quality of recognition or synthesis system. So here you can see the symbols of current alphabet on the table and intermediate alphabet, which we prepared for this system. And here you see the international transcription, because there is a Cyrillic alphabet. Maybe you don't read them, but you see the transcription of sounds. And you see that some signs they didn't need for the Kazakh transcription, because we didn't use it. We have a harmony law in Kazakh language, and this is two signs for to show the that they don't have any sounds, but they show that sound is mild or like strong. I can show you an example. So, okay. And then we did some analyzing of natural language sounds. Of course, we need it for the transcriptor, but I didn't talk a lot, because I think that here presented people not philologists, but they are computer scientists. So we did this work and analyzed that in the Kazakh language we have 9 vowels and 22 consonants. And then we preparing some notation for vowels according our analysis. So we have G1, we have set of hard vowels, G2 set of soft vowels. I can just pronounce if you're interested, like hard vowels A, O, U, E, soft vowels A, E, E. It's like pronounced in Kazakh, and so on. And then during the song, we have another set, like G3 set of non-labial vowels, G4 is set of labial vowels, G5 is set of backlingual vowels, G6 is set of front-lingual vowels, and so on. So we use these 9 sets for formalizing of phonological rules of sound combinations in the Kazakh language. And here you can see the groups of consonants like unvoiced, voiced. I think that's similar for every language, that they have unvoiced like k, k, without voice, and voiced like with, which pronounced with voice b, v, g, r, d, j, z, and so on. And other sonorous consonants, labial consonants, and so on, like for we did it for vowels. And then we make some description how we can present the alphabet of the Kazakh language. So there is set of all chain words of finite length in the alphabet A. Denote A like some unions of different sets. You can see on the slide. So we use some Greek letters as usual in math to describe that all equations. So here you can see the first phonological rules of sounds. I just explained one, and then maybe I stopped on only on examples. So you see that there are connection of two unvoiced consonants, and with on a connection of two unvoiced consonants in one word, or in case when one word ends to an unvoiced consonant and another word begins from unvoiced consonants, both consonants remain unvoiced. I think it's clear. So here you can see the description like alpha is in gamma, alpha is equal alpha 1x, alpha x is not epsilon, that it's not empty, x is unvoiced consonants that in S15 and so on, and then gamma should be like in this equation. So I just try to explain on the example, like you see these words, we wrote them on Latin alphabet like akpan, akpar. So there are two akpan, K and P unvoiced consonants, and akpar, K and P unvoiced consonants, and they continue to be unvoiced consonants. That means that these conjunctions is not occur for their pronunciation. Okay, here you see that we have the same situation when we see two consonants, unvoiced and sonorous. They can be like it doesn't occur, that they can stay the same, but sometimes it depends on the pronunciation. Some people can say like with in 2 and 2, like with when we see two consonants, unvoiced and sonorous, in one word or one case, with I need to read. In one word or in one case, when one word ends with unvoiced non-front tongue consonant, k, k, p, f, and another begins with a sonorous consonant sound, the unvoiced consonant is replaced with its matching sonorous consonant. So that means that we can say agnur before, but it's written like aknur, but it's pronounced like agnur. So that means that when we programming the our transcriptor, we made these rules, and after this transcriptor, our program can say like agnur, and like in the previous example, like aknur, without changing the sounds. And the third rule, when during the connection of two consonants, voiced and unvoiced, in one word or the connection of two words, the voiced consonant remains voiced, and the unvoiced consonant is replaced with its matching voiced consonant. So, like in the example, sus, or kms, kor pronounced it like kmz kor, and juz pshach pronounced it like juz pshach. So there are two ways how to pronounce it, these words if we can see them just in the text. And the rules number 4, that's I think that it's laced. Yes, it's laced rule that during the connection of two consonants, unvoiced and voiced, in one word, the connection of two words, the unvoiced consonant is replaced with matching voiced consonant, and voiced consonant remains voiced. So vice versa situation, like two words, ak gul, pronounce it like ak gul. So it could be so. So when the sounds can influence to each other. And so this paper presents the results of the formalization of phonological rules in their application in implementation of transcriptive for speech synthesis system. So what I want to say is that the first we need to explain or describe all sounds which we need it or not in our transcriptor. The second, we need to prepare rules for if we can when somebody put text in the system, that system should prepare some transcription record with by pronunciation rules, and then we can pronounce them. So about the topic of today's session, I can say that sometimes artificial intelligence is not is a tool for some ethical issues, because as I said that our research shows that the person who was killed because of his researches before more than 100 years ago had very important researches for the Kazakh language, and they still, and nowadays we can show to all our society that he had deep researches in this and like to populate his researches. And I said about project again, that this project, we did it in our project, so we have another task for this person. We published all his researches like anthology, and every interested person can make some semantical request for any issue from his books or his previous researches. Thank you for your attention. Ready to answer.
Thank you, Gulmira. We have a time, very, very short time for one quick question. If anyone online have a question for Gulmira? Okay, maybe we move the question at the end all together. I go quickly to
your presentation.
Sorry.
Is it your presentation now?
Yes, to my presentation. Okay. Yes. Okay. So good evening. As I told you before, I will try to shrink this presentation because I took time for presenting the workshop issues that are very innovative. So the work I'm presenting is a joint collaboration with Rajdeep Niyogi from Indian Institute of Technology, Giulio Biondi, Valentina Franzoni, and Alessio Mancinelli. This is what I'm going to present is a ethical application of AI. So this is it's not so new tool because there have been a lot of examples of AI detection, especially for English. But of course, for Italian languages, there are not much such example. Any languages, as Gulmira before was talking about Kazakh language, application which involve the language are very, very specific. Of course, they have a common results that can you exploit, but let's say is a new work from scratch very often. So here I translate what it is. I don't give you an Italian phrase because you probably feel a little bad with Italian. But this is London, is a tweet. London attack, ask Google what the hell they want to do with Islamic, because if I ask, I get his insults on my art. They're all extremists. So you can easily understand how this tweet contains hate feelings. And also it contains what we call stereotypes. They are all extremists. This is a typical stereotypes to give a general view out of the specific context. What we have done in particular is to study this problem by using a data set which was given in 2020 in the Evalita competition. Is a competition promoted by a group of Italian researchers on natural language processing and speech. And we task different tasks. This is only one of the many tasks for Italian languages. The data set was made of about 7,000 tweets represented by text in the limit of a tweet, text, and emoticons. And there were over the 800,000, 4,000 we know 8 feeling, 2,000 to 2,700 with feelings of 8, and about half of them with no stereotypes and half of them with stereotypes. These tweets, I will recall later too, were labeled by people of the Italian Association for Natural Language Processing, which organized Evalita. So our process was quite standard, let's say, in this area. There were some work of pre-filtering, pre-processing and filtering. We eliminate the specific strings, Italian stop words. We mapped emoji into text symbolic representation in a symbol such that the system can learn, let's say, the role of emoji. We don't operate stemming. Surprisingly, we did some experiments and we find that stemming in this area is not, it doesn't give a significant improvement. And we analyze a lot the word frequency of 8 stereotypes classes. So we consider the frequency of word in sense labeled 8 speech and stereotypes, sentence label pure state stereotypes with no 8, the sentence label no 8 with the stereotypes, and the sentence label a speech but not stereotype. Basically, the four combination of classes we were considering. And of course, we find the surprising things, that the word frequency of the 4 classes, 8, non-8, stereotypes, not stereotypes, of course, you can also consider a phrase can belong to 2 different classes, the 8, non-8, or stereotype, not stereotype, so can be both or one single. We found out that there's a large overlapping in the frequency of the words that they are using. Basically, because often Twitter answer to other Twitter, and so they probably use a similar word. The things that is instead significant is the word frequency of the classes. We found that the set of, let's say, most frequent 20 words is largely the same, but the distribution of frequency significantly differs in the different classes. So of course, there are some words that are more frequent in one classes and not among the 20 most used word, but in other classes. But many of these words, they overlap. And if you consider, for instance, this word Rom means gypsies, or is a word for these people, nomadic people. And so in 8 speech, Rome is in this position as a frequency word, is the most frequent word in non-8 speech. And the word Italian, for instance, is in this, more or less in the same position, and the Rome and Italian are very far away in non-8 speeches. And the same analysis have been done for stereotype classes. This is the frequency in the whole data set. This is the frequency in the data set limited to 8 and non-8. And if you look at overlapping words, you find that this is a situation. Here you have a graph which represents the frequency I. This is 1020 occurrence of the word Rome, and this is 300 occurrences of the word Rome. So basically, these graphs are quite different on average. And these are other interesting parameters which differ is the sentence length in terms of numbers of characters and number of words, and the classes stereotype and 8. They have a significantly larger number of characters. So basically 8 speaks more. They are more, looks like they speak more, and even people who do stereotypes. And we also analyze, here is a picture, but the analysis, of course, was made with the equivalent textual equivalent of emoji, is the frequency of emoji. You can easily see this is apparent here. You see these are the top emoji. This is still one of the top emoji, while this one is going down and so on. And of course, there are some emoji like this or thumbs up, but they don't appear. They don't appear so much in the other. Yeah, of course, so this is just statistic analysis. Intuitively, I say this is a positive emoji. No analysis of this type, just a pure statistical analysis. Basically, what we have defined as a feature to consider after this analysis, we try to embed this information of the number of words about the top 10 most used words. So we didn't give any distribution in terms of numbers, but just how many of the words used in this phrase are among the top 10 in 8, non-8, stereotype, and so on. And the same for the emoji. Okay, so we have done basically, and then we also consider some other classical, let's say classical, typically feature like fully capitalized word. People usually in tweets shout, when they shout, they use capital letters. Words mention of other users, doesn't matter who, but how many mention, and so on. Usually people who mention others are more, let's say, more excited when they talk. So what we have done then is to apply this set of features to both for hate speech detection. We built 2 different classifiers, one for hate speech, one for stereotype detection. And basically they share the same structure. I'm not spending so much work here, but what we have done is to, we have a layer for word embedding. I'm not introducing the word embedding. And we have a layer in which we concatenate those textual numeric speech derived from text that we saw here. There are 21. We combine them, and then we use a 3-dense fully connected layer with activation function, different activation function as you see here. And what we have done basically is to train this network with the data. These are the details of the algorithm, Adam optimizer, categorical cross entropy loss function, and different number of epochs have been experimented. I'm talking you to this in a minute. Basically, the data workflow is to do the pre-processing and feature, calculate numerical feature. We split the data as 80-20 training, test, and data set, and we submit the data to the neural network. We did this for 8 speech detection and for stereotypes detection. And what we have done is we have experimented the 3 categories of experiments. The full experiment that will correspond to the network and the input that we just described, text features and embedding. And separately, we trained the network considering only embedding or only text feature. This was done in order to have a more deep understanding what's going on. I'm just going to the results. The results are quite, let's say, quite positive. The best result that we obtained as expecting was in the situation where the embedding a text feature, we go up to 75% accuracy. And, but surprisingly, we also have a good performance of word embedding. Basically, word embedding only almost reach the whole complete accuracy, maximum accuracy. Although there is a 3% increase with respect to word embedding, they reach a remarkable accuracy. That means that word embedding is, let's say, excuse me for the word trick, word embedding embed many of the textual feature as well. And for stereotypes, the performance was not so good. It's lower. I will discuss in a minute one of the possible explanation for this is a 69% accuracy. Again, the word embedding test feature is the best results. And even in this case, word embedding is performing quite well, is very close to the maximum. So the contribution of text feature is good contribution, is very small. I go to my conclusion, and as I promised, I will be quick. We observe very positive and promising results for Italian language. Not so remarkable, outstanding, let's say, but good, positive, and promising. And we perform quite well with respect to the competition, let's say. We reach a precision. This is a positive 69 for stereotype detection, 75% for hate speech detection. And of course, as I say in the last line, we need to improve in general. We observed it should be improved SD, they should be improved both, and further experiments are planned on different larger data sets. What is the contribution of our paper? The contribution most remarkable was the analysis of the distribution of frequency in different classes, the frequency of words. The words are similar because often a tweet is a dialogue between different tweeters. There is no information if a tweeter is an answer to another tweet. It should be useful, but it's not included in the data set. And so the words are often similar, but the top words are differently distributed. And this is a remarkable thing for this area, which can be used also in other languages. The other thing is that word embedding largely encapsulates text features. Of course, text feature increase of some percentage point, but only some percentage point with respect to the optimal performance. A second conclusion, I say two or two, is about the ethical issue that we face. First, and this is the consideration I anticipate before, Hate speech is easier. Why is easier? Because it's more polarized. It's easy to say this speech, this tweet is an hate speech. Anyone can do that, more or less. The other problem is that stereotypes are more complex even to define. To say, you are saying a stereotype, you need an higher cultural level to say that the person is using a stereotypes. Because often the person is not aware to use a stereotype. In general, with hate speech, and especially for stereotypes, we have a problem of labeling. There is, despite of hate, is more or less is very clear what is hate. Nobody want to support hate, no? It's also self-reference, they say, tautological assertion. We are good, we are, okay. Labeling, there is no objective labeling. Someone is doing labeling. In this case, I consider the labeling reliable because it was done by natural language processing members of the NLP's Italian Association. But it's impossible to avoid implicit embedding of the opinion of the person who write the label. For instance, if there is in many tweets, there are some political subject people. They are mentioned Italian political people. Maybe if you don't like that political you tend to label negatively. It's almost impossible. And labeling reflects the prejudice and opinion of human labelers. So of course, I consider sometimes objective. You have a prejudice, but it's also something that can be. And what we are working in now from the ethical point of view is to integrate, don't just take the data set as it is, but to integrate with other data sources. For instance, it would be interesting to have profiles of the labelers, to know that a tweet was classified by the same person of another, maybe even don't know who, but to know this tweet is. So when you train, you can also represent the distribution of people who give the labels. And that would be to avoid a certain kind of bias, okay, or to be aware. And so the aim is to reach more transparencies, to make labeling lecture the meta information of labeling and their role. Okay. Okay, I finished my presentation. Of course, maybe we can, thank you very much. Maybe we can consider some more questions later after.
Like
The next presentation is, again from our groups. And is speaking Giulio Biondi. Yes.
This one? Yeah.
From University of Perugia.
No.
It's already sharing, right?
Yes, it's
Thank you. So, good afternoon, everybody. I'm going to present our work on student behavior models for a university learning management system. The goal of our work was to build some student behavior models which can be used in turn to predict the final outcome of exams. We tested our system and developed it in a blended learning environment context. It was a university course which was given in person and supported by material and tests on a web platform. The context is that of adaptive e-learning systems, in which the system adapts to the user profile according to some factors, which we will see later, and can possibly provide, for example, early warning to predict the student's performance at a future time, and personalized learning paths based on the model the system develops of a user. This is a definition, a very comprehensive definition, in my opinion, of an adaptive learning system, in which the flow is the one you can see on the left, schematized. So the interaction between the learner and the learning content produces some information on the learner. Such information can be used by a system, for example, a machine learning system, as in our case, to produce a learner model. Such model, when produced, can be fed to an adaptive engine, which is responsible for selecting the correct material, for example, or providing learning paths, and, which is not shown here, also provide feedback to the teacher, who is responsible for the course. Then the newly chosen content is provided to the user, and the new interactions produce another more information. The information which can be used to create student models can be summarized into categories. The first one is the user explicit data. So, for example, at the time of enrollment, users can be asked to provide information about them, which can then be used to personalize their experience in the beginning. Such information, while useful, is often not reliable because it's totally dependent on the willingness and fairness of the user to provide correct and detailed information. Then also quizzes and surveys can be administered through a course in a continuous learning environment to assess the performance of the student and then possibly take action. We also have another category, which usually comes from the system logs data. Each e-learning platform produces a vast amount of logs, which, for example, record the accesses of the users to the platform, the interaction patterns between users and between users and learning material. And both categories can be used and integrated to produce a user model inside the platform. For our work, we focus only on system logs data. Okay, so data that that is recorded automatically by the system and then can be exploited for our purposes. We worked on the famous Moodle free open source learning management system, which is widely used at teaching institutions and private companies. The learning paradigm of Moodle is based on the interaction between the user and the material, and between users also in a collaborative learning environment, and allows also teachers to have a track record of the students' activities, both in terms of quizzes and also in terms of interaction with the system. The information in a Moodle learning environment is organized in several database tables, and we focused on the log store standard log table, which holds the information on all the events which happen in the platform. Specifically, the events we considered we selected 4 attributes, so the user ID, of course, who generated the event, which kind of event, more on this later, when the event occurred, and also the object ID, also more on this later. We selected the following features to build a user model for our work. First, the total number of events generated by a single user. Then the number of course accesses per week and per month. This is based on the intuitive assumption that a student who follows a constant and steady path in learning with accesses regularly distributed throughout all the course will be more likely in the end to have a positive outcome for the exam, rather than a student who, let's say, connects 2 days before the examination and tries to learn everything at once. Then we have the number of viewed discussions. Moodle offers also the opportunity to have forums, which can be used to promote discussion between users and also to as a mean to give information and communications to the learners. And the number of viewed resources, since in our course the platform was used also to give course material to students. So the more resources they saw, hopefully the more likely they were to again to pass the exam. And of course the exam outcome, so whether they passed the exam when they tried it or not. This is a distribution of events per month, which shows that actually students connect just before the exam, at least the majority of them. The peaks you can see in this picture correspond to months where the exams were administered, so yeah. But we can also see some interaction in the months before, so especially this is when the course was administered actually. And we can see the same pattern when we divide the events per week. Peaks correspond to the beginning and also the exam dates. For our experiments, we designed two machine learning algorithms. First, an artificial neural network, which takes as an input the features and then has three fully connected layers. The first one of 32 neurons, the second one 16, and the last one of 1, which is the one who actually classifies and gives the output, exam passed or exam not passed. And also support vector machines with two different settings. One with linear kernel and a C value of 0.1, and another one with the RBF kernel with a C value of 100 and a gamma parameters of 1 to the 10 minus 4 power. Such parameters were chosen after an extensive testing phase in which, with a grid search approach, we decided which were the best settings for our experiments. In total, we selected more than 90K events after pre-processing, so discarding events which were not useful or which occurred before or after the course starting date. And we produced two data sets. The July data set is composed of 340 students and follows this time span, and considers the students who tried to pass the exam right after the course. So in the 3 dates immediately following the ending of the course. Usually students who are more skilled or more prepared try the exam immediately. So it was worth to see if there was any difference between such group of students and all the students which attended the course, who are considered in the April dataset, which follows this time span until the last exam session for that course. we followed a five-fold validation approach and calculated the metrics shown here, so accuracy, precision, recall, and F-score. So these are the results. The results for the July dataset are as follows. We achieve high accuracy scores with the SVM linear model. In particular, 85% of correctly classified students who passed or didn't pass the exam. And also good results with the SVM model with RBF kernel, and slightly lower with the artificial neural network, albeit still 80%. And we can also observe a substantial difference between the two classes. So the models are all able to predict better the class 1, which means exam passed. Probably just because of a higher amount of samples in such class for the first data set. Actually, we can observe that for the second data set, in which the number of samples is higher, also the accuracy values are much higher. We get to a maximum of 96% for the first model. And also the difference between the two classes are leveled. So basically we have the same performance for both the classes. And also the other models perform well with 90% and 89% accuracy. So in conclusion, we developed student behavior models to be used for the prediction of the final outcome of exams, to be used in an adaptive learning context to produce early warning and personalized learning paths. We developed two different machine learning models, artificial neural networks and support vector machines, of which the best proved to be the latter with linear kernel. Future development will see further testing of massive open online courses, in which hopefully the amount of data logged is even higher and thus producing better results with machine learning systems, and also to integrate the information with explicit information, for example, of quizzes, results, or user feedback, where this is available. So thank you for your attention.
Okay, we would like, I mean, we are late, but not so late. So we may have time for one question, even including the previous talk of Gulmira, my talk, and Giulio Biondi's talk. Please. Go ahead if anyone has a question, please. Ok, puoi venire qui?
Okay.
Can you? So we have a question. You can, yeah.
Okay. Okay.
Yes.
I studied many times when I was student, after a master and after PhD. All questions that are regarding soil, the value, the evolution, and so on. And one of that was the most fascinating aspect was the classification of soil, but not only with one, how to say, channel. Okay.
Okay.
Okay, for instance, trying to understand the real estate value. Okay.
Yeah.
But also the biodiversity and so on. So you can have a lot of parameters as you showed. Okay. But many years ago, a professor that was from Sardinia, Giovanni Maciocco, was speaking about geography or environmental value. This was like a general approach. Okay, how to specify the value scale, okay, was on charge of the researcher, okay.
Yeah.
Do you think that this is flexible in the same way, just to allow the use of different indicators and so on? Or can you speak about the flexibility?
Yeah, I think we have to distinguish between first machine learning systems and deep learning systems. The two approaches we saw here are machine learning systems, in which the general approach, of course, is the same, but the knowledge of a domain expert is required. So this approach, of course, the features are different. So for another problem, it is required to have an expert of the other domain who will select the appropriate features, which will be, in his opinion, and according to previous literature, the most appropriate to have a successful result, and then feed them to the system. Traditional machine learning system, yeah. Recent approaches leave this with deep learning, leave this phase to the deep learning system. So that depends on which approach we'll take. For this reason,
maybe the scope is also light.
Yeah, it's a different approach.
Okay,
You're welcome.
Thank you for the question. I'm sorry but I'm happy to give you a reminder that we have a coffee break now and we are late, and then we are waiting for the next part of the session.
Prendi la penna? Poi la stessa cosa lei? Andiamo a provare? Il duplicare prova, vedi se ha ragione Lucia. Siamo già impossessati.
Infatti, via quella è mia.
Alfonsone.
Cosa c'è qui? Cosa dice?
Chi comanda? C'è scritto.
Alfonsone, sì,
c'eravamo.
c'era, però non c'è.
Detectare
Non va.
Cosa succede? Per fare il doppio.
Esatto, il doppio schermo.
Ah.
Cosa del pantalla avanzata? Pantalla 1 Epson. E questa qui, cos'è infatti? Perché pantalla 1 sarebbe questa qua.
Sì.
No,
abbiamo quando non risolvi questo.
Perché riconosce proprio la roba del proiettore come la pantella, nel senso schermo 1. Oi. Se controllo e questi qui ho visto, cioè micro video mute on off audio
PC portatile, spinge accendi, però vorrei fare
no.
E questo dice
quei due non
tocchiamo.
Questo dice di fare po'. Allora, proviamo quello. Questo non si chiude. Montiamo forse. Come vuoi fare? Mettere.
Carico le altre presentazioni?
Sì, certo. L'ho messo qui per caricarlo. Quindi...
Sì, no, che ho questa l'avete
Sì,
già...
la nostra.
Posso toglierla? L'avete già...
È qui, stiamo
sì,
messi
sì,
su
sì.
testo, presentazioni X.
Sono entrambi gli
Questa è la cartella sul destro? No, questa è,
No,
è
questa è la
D.
pennina.
Ok.
Presentazioni X c'è dentro.
Vabbè, non so se l'avete già fatto.
No,
No.
Ok, lo copiamo.
Grazie.
Ma qui ci sono tutte, anche...
Sì, c'è la mia e quella di Fede.
Ah, ok, perfetto. Allora metto qui anche la mia e
Vai.
dell'altro relatore. Grazie ragazzi, scusatemi.
No, non c'è problema, proviamo a risolvere questa cosa, se non si risolve si fa...
Ma avete provato a chiedere se si può collegare un secondo computer?
No, però non abbiamo il cavo. Questi
C'è un fascio di cavi qua, però, guarda. Qua.
L'ho fatta un po' solenne.
Sì. Quello, magari se provate con un computer lo usate come monitor, magari funziona. Non lo so.
Allora, forse ci occupi degli aspetti tecnici.
Sì, assolutamente. Come recita il mio badge.
Io l'ho perso il mio badge.
Bello.
Mi è piaciuto, c'avevo solamente il collarino. Quindi...
Si prova, vediamo come si fa. Questo palco qui è...
Okay, no, I copied your presentation into the desktop. I will open the presentation.
Cool.
Don't worry.
This is the best way.
Don't worry.
Sì, il badge è problematico.
però anche avere il badge rubato è nota di merito. Che rubino il badge è nota di merito. Non trovarlo più libero di che qualcuno ha detto.
Ma il badge va così, non è che...
Se
È
fosse,
un mercato nero dei badge.
se fosse ieri dicevo no, ti hanno rubato per andare a... E pressione in più. Pressione in più.
Ok, sono le 16:39, quando vuole...
Pressione in più, dico.
Sì, devi aspettare qualche minutino per...
Tranquillo,
Ci diciamo 5
respect to the schedule.
Okay, welcome to this session of the ICCSA conference. The chairman is Professor Cutini from the University of Pisa.
Thank you, Alfonso, and welcome to everybody here and in the global web as well. And Alfonso, can you give me the program, please? Here, yes. And I open this session, which is dedicated to configuration analysis cities. And I'm glad to invite, as the first presenter, Veronika Kaleyeva. Please correct my pronunciation if you need it. Piotr Werner and Mauritius Posek. And a presentation of the contribution entitled Drivers, Wildcards, and Spatial External Effects of Urban Sprawl in Poland, 2016-2022. I would say 15 minutes, about 15 minutes, so as to give 5 minutes more for some discussion. Please, you're welcome.
Yeah, just but not PDF. Yeah.
One moment to check the audience. Okay.
Great. Thank you, Valeria, for introducing. I wish my senior co-authors could be here today with me. They are Piotr Werner, who is my supervisor and the head of our team, and Mariusz Torczek, who is an expert in geographical information system, and I'm a PhD student at the University of Warsaw. This is an outline of my presentation. I will start with a really short theoretical background, explaining the main definitions. I will try also to mention the main events that we consider to be extremely important in the context of our study. Later, I will proceed with the discussion of data and research methods and results. I will also try to consider limitations of our approach and opportunity for future studies, and I will close my presentation with discussion and conclusion session. So for the purpose of our study, we define suburbanization as population shift to suburbs, resulting in the rapid development of the peripheral areas of the city and thus urban sprawl. In our study, we try to quantify and visualize the development of cities and suburban areas by measuring new housing constructions. There are a lot of drivers of urban sprawl that are widely discussed in the literature, and suburbanization is just one of the dimensions. And it's really challenging to capture, to testify which particular factor could be a driver for sprawling in this particular time and place. We suggest that it should be rather usually a synergic effect of a couple of different factors that would combine in the final result. We also refer to the concept of wildcards. These are those unexpected and astonishing, shocking events that's normally considered to be unlikely, but when they occur and happen, they fundamentally affect the condition of societies. In the context of our study, we defined two such events that were important to our area. The first was COVID-19 pandemic waves and lockdown. We suggest that it could influence a lot the housing preferences of population and general lifestyle. We assume that probably nowadays more people would more prefer living outside of the cities. And the other event, the breaking event that could possibly have the opposite effect on suburbanization phenomena is the war in Ukraine, which is neighboring Poland, and it affected Polish society in many different ways. And one of them was a huge number of refugees from Ukraine who crossed Ukraine-Polish border, and the housing market reacted immediately with highly rapidly increasing prices for housing. On this graph, we can see that during the first 3 weeks of the war, almost 2 million of people were fleeing the war. Later, this number was increasing, but from the other hand, a group of people were returning back to Ukraine. Perhaps it were people who were coming back to their homes where the situation were stabilizing, and the other group were men who were going to fight. In our study, we try to visualize, to identify the main urbanization areas in Poland. We also try to capture and to somehow tackle the tendencies and trends of urbanization. So our main hypothesis is that progressive suburbanization remains stable in Poland despite of different stimulants, destimulants, and nominal factors we take into the account. As a main variable, we use dwelling completed per 10,000 inhabitants per year in the study period, year by year. And as an approach, we use location quotients, or in another words, regional index, that demonstrate the ratio on a particular value for social phenomena in a smaller spatial unit to compare to the higher spatial unit. In a context of our study, we try to quantify dwellings, new constructed dwelling, residential construction in particular county to compare to the national average. On the slide, we can see the number of new dwellings completed in thousands starting from 1915, and we can see that during the study period, this number shows great growth. Yeah, I think, yeah. So basically, the result could be demonstrated on this map. We considered as reference years 2016 to 2020 and 2021. We visualize the areas that are most and least urban, under the process of urbanization by location quotients. So the areas that are marked with purple are the boundaries of cities. So we can see from this slide that there are areas that create, let's say, bagels around the white islands that are the city center. And this was actually our idea. We wanted to see how distributed spatially, and this was the effect we expected. Now I will switch it to show the difference between different years. So it was 2016, 2020, 2021, and once again, so 16, 20, 21. So this swift change demonstrates that actually this area do not change a lot. And basically on this data, it's really hard to define any strong tendencies. We can only see that in some areas, it looks like urbanization process are intensified. So we really wonder how the situation is developed. It's really hard to predict in terms of both factors that I've mentioned before, these white cards. Speaking about the limitations and opportunities, I think our main limitation concerns data, because that situation changed rapidly, and the statistical offices and institutions were not so fast as we would like to be, but it's natural, it takes time. So anytime we make research a bit late, and the other thing that is important is a time lag. Different processes we consider also has their life cycle. So we do not consider it in both cases, and in case of developing residential construction, and the change in perception and housing preferences of population has its own dynamics for sure as well. So these two issues are not, I think they are underexplored in the literature. So it could be a good path to develop our study. I wouldn't discuss the opportunity because I can see that I still have a couple of minutes because actually we use some of these opportunities in our future publications. It will not be reflected in these proceedings, but we are ready with another paper, and I'm happy to present you shortly these results. They're rather fresh. So what we have done is the first one was we use the same approach, harmonic means of location quotients, to smaller spatial units, to communes in Poland, and it allowed us to get a more precise picture. The other development referred to comparing some data sets. The first one was once again location quotients, and the other one was the data from global human settlement layer. We took different classes of areas, urban, like starting from the most rural and ending with the urban ones, and we tried to take these data ones together, and to make it simpler, probably the areas that you can see like blade areas. These are the area of the most important, of the most intensive urbanization, where the location quotients had the highest values. So on these pictures, once again, we can see on this big bright part, these are main cities, and here we found once again the same finding that most of the areas that are urbanizing rapidly are suburban and peripheric areas of the city. And last but not least, things that we have done, we used the classes of urban areas starting from very low density rural to urban center areas, and estimated correlation with location quotients. Once again, location quotients reflected the extent of urbanization dynamics. And here we can see that the highest value of correlation was for suburban and peri-urban area. So this estimation somehow proves in numbers our preliminary suggestions. And coming back to very short conclusions, I think it was already discussed more or less. We found that our study testifies progressive suburbanization around the main Polish cities in the study period. So there are areas that seem to be to grow more intensively than others, but there is no evident pattern of these changes. And despite the tendency for a strong development of residential construction, it's really hard to say where these urbanization dynamics related to critical volumes of investments outside of the city will stay in longer perspective, because there are a lot of different factors that can influence this. Thank you very much.
Thank you very much, Brian, for stay here.
Yeah. Okay.
Thank you
Yeah.
for your nice presentation, which
Thank
I did really appreciated. Is there any question to give? Please.
Thank you for your presentation. Congratulations, it's very interesting work. It's just a curiosity about what related to your future endeavors of this research. Have you thought about considering the road network and the evolution of the road network in the measurement of this problem? Or your work will not cover the logic of evolution of the road network?
I think it's an important issue because the red network has a direct effect on the functional urban areas, and this is actually one of the indicator taken into the account. We are not doing it in this study. Generally, my PhD thesis will refer only to Warsaw metropolitan area, and I'm not sure, but I think this would be one of the issues that could be explored. A couple of years ago, we made a research based on volunteer and geographic information data, and it was very nicely evident, like the roads can influence the commuting patterns and, of course, the residential construction development around the cities.
Because it's an expressive area, it's collect out but you could begin with small issues and see how it, let me say, you can mount it like a jigsaw to see how the logics of this problem open evolution of it. Very interesting. The work is very, very comprehensive, very nice. Congratulations.
Thank you for this suggestion. It's for sure important issue to consider.
Oh, yeah. One more question from my side. Sorry. The results you presented seem to attest that there is not strong influence of the actual process due to the black swans of the coronavirus and the war. I mean, but have you had the possibility of recognizing some long-term trends referred to change in, for instance, in behavioral patterns? I mean, for instance, the use of private car or preferences for shopping in the shopping centers, also phenomena which generally foster suburbanization processes. And we recognize something of that kind of.
I think that the trend that was demonstrated during this presentation was actually a continuation of the previous trends. It looks rather similar in the previous periods of time. And the general dependency is that the big cities in Poland is still growing, but the medium one very, very often are shrinking. But when we analyze suburbanization, we can find that actually it refers to any cities, and it's I think it's a unique distinguishing feature of Polish suburbanization, that not only big cities or small cities are sprawling, but even those shrinking that are losing their function. Even those cities are shrinking. So we do have two processes in the same time. Yes, from one side the city is shrinking, and from the other side the suburban area gets more important functions.
Thank you very much. Is there any questions coming from the web? I don't know if it's possible to catch them, or maybe go ahead.
At the moment, we have no questions from the
virtual. Is there any question? Oh, no.
Okay.
All right.
Thank you.
Thank you once more.
Thank you.
I get the program, man. And the next presentation has this title: Accessibility and Mobility in the Small Mountain Municipality of Zafferana Etnea, Sicily. Coupling of walkability assessment and space syntax. And the authors are Antonio Russo, Tiziana Campisi, Giovanni Tesorieri, Alfonso Annunziata, and Chiara Garau. I invite you, whoever, to present it.
Thank you very much.
I don't want to present, but just to introduce this work. Okay, there is also online Antonio Russo.
Antonio, can you hear us?
Yes, I'm here.
Okay.
Oh, thank you.
Can you show your face just to demonstrate that you are with us? Okay, perfect. So, okay. So this work Okay, the title is Accessibility and Mobility in the Small Mountain Municipality of Zafferana Etnea, and starts with a PhD course that I lead with other colleagues that has a topic smart sustainable cities. And this is, I'm really happy for this kind of works, because finally we can succeed in publishing something, doing a specific course, and we are not speaking about San Benedetto district, because all people that work in this workshop finally did the same workshop on this case study, but in this way, in this paper, we will speak about a little municipalities of the Sicily, Zafferana Etnea, and there are the different main words that we bring for construct, for build this paper, and we start from for how much we can evaluate the impact of the pandemic, and how we can evaluate in a little small municipality of a mountain municipality of Sicily. So these are the four principles for urban adaptation, and are rebuild an urban economy, reduce poverty and inequality, clarify urban legislation and also urban governance, and reorganize form and function of the cities. So you change the presentation, because we are speaking about the Zafferana.
Yes.
Okay.
So the area of study is the municipality of Zafferana Etnea in Sicily. I invite our co-author, Antonio Russo, to introduce the case study.
Hello, everyone. Hello, everyone. Thank you, Professor Garau. Thank you, Alfonso Annunziata. The area studied is, as they say, the Zafferana Etnea, a small town in the southeastern side of Mount Etna. It has more than 9,000 inhabitants, and it is the biggest municipality in the southeast side of Etna by sides. But even if this geographic dimension, only a small portion of the area is suitable for human settlements, because around 8% of the territory is covered by Etna Park, which is subject, obviously, to severe naturalistic restrictions. Moreover, the territory has a high level of tourism for the volcano's proximity and several food and wine events. Alfonso, next slide, please. Okay, but why the case study of Zafferana Etnea was chosen? Because of the morphology of territory, because of the frequent and serious seismic and eruptive phenomena due to its geographic positioning near to the highest active volcano in Europe. We are talking, as you can see from the time series in this slide, several, more or less, one critical earthquake every 20 years occurred in Zafferana. This, both with the mountainous morphology of area and the slow but widespread aging of the population, make this zone very risky and interesting to study, especially in terms of accessibility to basic service. In this slide is shown the main points of interest of the historical center of the municipality, that is the area that we focused on. The historic center is characterized by a strong concentration of the inhabited areas, and by the location of most of the public service, like schools and town hall. So, as you can see, you can see the main roads highlighted that are placed on the level curves of Mount Etna, so guaranteeing relatively low slopes. Methodology used will be showed by Alfonso Annunziata later.
So, Antonio, thank you very much. So the main objective of this study is the preliminary part of an ongoing research on the evaluation of workability conditions, and as a preliminary and necessary phase in the construction of a knowledge framework for that process of reorganization of the urban structure, which is particularly relevant to adapt the built environment to the post-pandemic scenarios, in particular in relation to the deep changes produced by the COVID-19 pandemics in the transport and mobility sector. For instance, the needs for proximity of services, the need for urban spaces conceived as space of social interaction, but also the reduced utilization of the public transit system and the more intense use of alternative forms of mobility, including, of course, walking and cycling, but also other forms of shared mobility, of also shared micro mobility. So the preliminary stage of this study focuses on the configurational analysis of the municipality of Zafferana Etnea. The configurational analysis is aimed at describing the spatial relations among the urban spaces that compose the urban layout of the municipality of Zafferana Etnea, of the area of study. In particular, it is aimed at identifying those areas, those spaces that are particularly integrated and central, that present an high potential, both in terms of accessibility and in terms also of mobility, of transport, of movement at different levels of scale. So our methodology is articulated on 4 stages: the selection and characterization of the area of study, the construction of the segment map, the the segment angular analysis, that is the calculation of the 2 metrics of normalized angular integration and normalized angular choice, calculated at different scales so as to highlight the potential as destination and the through movement potential of spaces at different scales and in relation to different types of movement. And then the identification of those areas which are both integrated and accessible at the local and global scale, and thus those areas that emerge as potential vital areas and portions of the municipality, of the area of study. So the results show, as we can see here, the distribution of values of normalized angular integration and normalized angular choice with a radius of 300 meters. This analysis is relevant to highlight spaces accessible and important as paths, as routes for local scale movement. In fact, here we can see that the segments, the streets that compose the core of the historic center of the municipality emerge as central and integrated space. We can see also that in relation to a different scale, to a broader scale, a different subsystem of spaces emerge. In fact, we can see a grid-like structure emerging both via the analysis and measurement of normalized angular integration and normalized angular choice, while at the global scale we can see, in particular in the case of choice, which determines and describes the through movement potential of a space, that is the probability that a space is comprised within the shortest path from any region to any destination. We can see a subsystem composed of a sort of ring in the southeastern part of the municipality, of a grid-like structure that embraces part of the historic core of the area and of a centripetal radial subsystem in the northwestern sector of the area of study. The last step of this analysis was the identification of those areas, of those potential centers that emerges both at the local and at the global scale. And as we can see, we can identify, we can recognize a radial structure of spaces which are central and integrated both at the local and at the global scale. We can thus presume that these spaces can be considered as a potential vital center within the municipality of Zafferana Etnea. That is an area where different functions, different practices can gather and can intersect, and as a result, an area where a further evaluation of conditions of coexistence among different functions, among different practices becomes particularly relevant, and in which, in particular, redesign, reorganization of the space so as to accommodate different functions and so as to promote, to favor different forms of use of the space, in particular from the point of view of the pedestrian, becomes central and becomes particularly significant. As I was saying before, thus the configurational analysis underlined the emergence of different spatial subsystems at different scale that highlights different condition, different potential condition of utilization of urban spaces in the area of study, and in particular the comparison of levels of integration and centrality and choice at different levels of scales allows for the identification of a potential vital core in the study area. The future development of this research will, on the one hand, it will broaden our analysis on also the peripheral areas and the areas of dispersed urbanization of the urban sprawl around the compact center, the compact districts of the municipality of Zafferana Etnea, but also will focus on those areas which emerges as area of concentration of different uses, so as to evaluate the different conditions that can influence, that can determine the different affordances in terms of utilization of the spaces, in particular looking at the land use variable, the built up areas variables, the urban design variables, that is the microscale factors that can influence and impact the forms of perception and experience of the space, and of course the mobility variables, indicating also the integration between the walkability, the dimensions of walkability, and the other larger scale forms of transportation. Thanks for your attention.
Really only to underline just a little, a small detail that this work born with the collaboration with the different sector, and this is a really first work. So for people as Professor Puttini and as the collaborator of Valerio Puttini, this could be easy work, but for us it's the first step also because the colleagues are in the mobility sector and the managerial sector. So we'll try to present the space syntax topic in another sector in order to put inside this world other people. So just
thank you also for your on the menu. Seems really interesting. What is there any question from this room to Alfonso and others? Is there any question?
I would like to ask something because I'm interested about what Professor Garau says. I mean, what was the? I'm curious about what was the response from people from transport planning and field about that. I mean, we need the results. We see the results, but I'm interested to know something more about the process. You think?
Basically, it depends on the people that want to work on it. And in this case, it was easy because Antonio Russo and also and also Tiziana Campisi that worked with us, worked with us with this specific topic, was really collaborative, really interested in working together in this topic. So there is a big interest for learning something. So generally, it's really difficult because for working together, you must do some step back for go on well, but it is not this case.
A couple of questions from my side to Alfonso and Chiara, and of course to Antonio. Is a general question and a more specific one. The general question about the actual correspondence of the configurational values we have found to the actual functional layout of the settlement. Of if you have verified such form of correspondence. In other words, the streets that you have highlighted as central ones are actually the most crowded and busy and crowded with people and activities and movements and so on. Okay, and the second more specific questions regards a conceptual, it's not a technical detail, but I would say a conceptual issue. Which is a criteria you have adopted in defining the perimeter of the system, enclosing the system with respect to the rest of the neighborhood. So, which is an important question, of course, not only in configuration analysis, but also in any systemic approach, of course.
Okay, thank you. And I will start from this last question. We have adopted as a criterion for the selection of the area of study the criterion to focus on the compact part of the urban settlement, on the more consolidated and historical part of the municipality of Zafferana Etnea. Of course, in a second stage, in the future development of this research, we will broaden our area of study, and we will adopt also a different method for the delimitation of the area of study. For instance, we could use a dilation algorithm to identify the most important and relevant settlement cluster within the region, within the municipal area intended as the administrative boundaries of the municipality of Zafferana Etnea, so as to highlight the different clusters and focus on the main emerging cluster, including, of course, the compact city and the main agglomerations that characterize the area of expansion of the urban settlement. So we are also going to refine the method for the delimitation of the boundaries of the area of study. With regard to the first question, we actually have observed that the analysis tends to highlight the areas, the streets that shape and characterize the morphology, the structure of the very central core of the compact districts of the city of Zafferana Etnea. So there is a correspondence between the main, in particular, longitudinal axes that shape and inform the structure of the municipality of Zafferana Etnea and the segments that emerge from the configurational analysis. Of course, the second stage of the analysis will focus on those areas emerging from this analysis to verify a correspondence between the configurational variables and the land use variables in terms, in particular, of density and diversity of uses and of services.
Thank you. Thank you. Thank you very much, and
thank you very much
for your work. Thank you. And let's go ahead and let's go to the third presentation. The title is Digital City Surveillance Models and Urban Security, Integrating ISO and Space Syntax in Realizing Adaptive Decision Support Systems. And I invite you here Federico Mara, my young colleague here, to present his pleasure contribution.
Here, yes.
Lo sistema, ci sono delle... Sarebbe questa qui. Ecco. Ah, sì. Secondo me c'è in condivisione, no?
No, l'ho fatto.
Ah, ok. Sì, ho visto. Ammazza, finita.
So yours.
Okay. So, good afternoon, everybody. I am Federico Maia, PhD candidate at the University of Pisa, with supervisor with Professor Valerio Coutinho. And for this paper, we face the topic of visibility and surveillance, as you can see from the title. In particular, this study illustrates the potential of new model integrating environmental criminology, isolist analysis, and configuration analysis in the development of a digital city surveillance model as a crime-fighting and urban planning support tool, being able to identify the more fragile urban areas. So, this presentation, as the structure of the paper, will follow these steps. A brief introduction about the urban security importance, then a brief literature review, just to illustrate the needed background to comprehend the potential of the proposed model, namely the environmental approach to security, the role of digital technology and surveillance in urban security, and the roots of visibility and surveillance, and then the schematic digital surveillance model that we have proposed. And finally, some conclusions and further developments are suggested. So, urban security, and in particular perception of insecurity, are fundamental factors that affect citizens' quality of life, inherent complex, then characterized by the unavoidable need for multidisciplinary studies. Then, the main fields involved in this research, namely sociology, criminology, psychology, architecture, and urban planning, between the 70s and 80s, gave birth to the environmental approach to security. Leaving aside here the theoretical development from the origins to the CEPTED, the focal point is the shift that environmental criminology proposes by giving the main role to the environment, intending both in its physical and situational interpretation. This led to the development of not obvious idea that the modeling, organization, and management of space can influence criminal behavior. On this basis, the so-called crime theories were developed, which are theories that seek to analyze the spatial and situational components that favor crime occurrences. But overall, we can ask ourselves, and this is the question, what is the role of digital technology in urban security? We have to say that the environmental approach to security in the last decades is getting new lifeblood from the technology, digital technology evolution from many points of view. In the theoretical advancement, as you can see, then in the elaboration of new models and decision support systems to aid planning and urban design, such as predictive and risk assessment tools, and in particular, agent-based models. Agent-based models, in particular, have developed considerably in the last 10 years, and they consist of models of interacting agents able to emulate human behavior, taking individual decisions based on few initial hypotheses, and able to forecast situational behavior and group behavior dynamics. And this is the important thing of this model. Finally, from the operative point of view, with the elaboration of technological tools and devices aimed at increasing security in cities, and in particular concerning the smart cities and visibility and surveillance aspects. In fact, crime theories examining in detail the role of visibility and surveillance, highlighting the deterrent power against criminals in a benefit cost and rational choice perspective. In fact, today, surveillance is still a primary tool in the development of security policies, which is also confirmed by the CEPTED recent guidelines. And in fact, turns out that at least 75 countries in the world are using AI technologies for surveillance purposes, and 66 are using facial recognition systems. And this is the focal point of our model, not all the countries and regions could permit this kind of surveillance analysis due to privacy issues. And that's the problem that our model tries to overcome. Then the last stone of our general background that we need to face this topic was the reconstruction of the roots of visibility and surveillance. So we asked ourselves, what is visual surveillance from a conceptual point of view? It has always been the leitmotif associated with security and has found a utopian but emblematic declination with Jeremy Bentham's Phonological, then becoming central in the theoretical crime prevention studies from Jane Jacobs onwards. But, and this is the important thing, just as in the graph theory, for example, referring to the emblematic Konigsberg bridge problem, the possibility to find a specific path depends on the inner properties of the graph. In the same way, visibility is a characteristic mainly dependent on spatial configuration and capable of affecting people behavior, as the space syntax theory affirmed. Therefore, urban visibility characteristics should be taken into account in urban planning and environmental design. So finally, just a few things about visibility, and in particular, an isolist is defined by Benedict as the set of all points visible from a given vantage point in space and with respect to an environment. And he suggested that the way we experience the space is connected to the interplay of isolists. Then Turner et al. Integrated the isolist concept with the graph-based representations, and in particular with visibility graph analysis. However, as Turner himself pointed out, it is fundamental to overcome the assessment of visibility in vacuo and in stationary terms by referring to fixed position. And our embryonic model works exactly in this direction, as we will see. Turner himself, who for years studies this topic, elaborated, in fact, an agent-based model with this scope. And from that, he discovered that, first, visual integration is not related to pedestrian movement, while the agents in its agent-based models are. Then, secondarily, he suggested to go back to simpler models of the environment in determining the agent logic of movement. So axial lines or sparse visibility graph between topological nodes. More specifically, Turner himself proposed the use of agent-based model to correlate human individual movement paths and configurational properties, which is the way our model works. The focal aspect, in fact, is that as humans, we continuously relate with isolists and we make decisions based on isolists, even without realizing it. Where we sit at the table, or where we wait for our friends in an environment, or what route we choose when taking a walk. Similarly, a criminal looking for the right opportunity to commit a crime will carefully assess the level of surveillance of that places of environments. And this is why the study of isolists and the development of surveillance maps as risk indicators can be decisive. And now, finally, let's pass to our model proposal. As I already said, it is a conceptual idea of a city surveillance model aimed primarily at urban security improvement, but also extendable to other types of urban analysis. Therefore, considering, as we have said, the studies carried out over the years on the subject of isolists and visibility graph analysis, the whole configurational theory and in particular space syntax, with its ability to interpret the human behavior within the environment, and finally, considering the importance of surveillance in environment criminology, the model was developed. So I will present it by reasoning for additional steps. So if we consider an environment as the one that we have here in the figure, and the person located there, it is possible to define and represent the isolist of that individual. It is also possible in general to study the view field of an agent moving according to a certain path in space, and therefore how the isolists vary in time. Moreover, it is possible to define the agent visual field properties on the basis of the agent inner characteristics or the type of analysis to be carried out. It could be set, for example, the width of the visual fields, as we can see in the second figure, hypothesizing the behavior of the agent. Similarly, it could be considered the reduction of the agent's visual field extension by making appropriate considerations regarding, for example, a specific type of crime that we want to analyze. Ultimately, it will be possible to represent for each instant the isolists of the agent leaving the environment with the designed visual field properties, as the third figure shows. According to similar reasoning, the ISO-list of digital surveillance devices can be represented, as the first figure shows, and they could be easily integrated within the previous representation. And we have the second figure that shows this aspect. Moreover, by integrating in a single representation the ISO-list of digital surveillance devices and the ISO-list of people experiencing that space, it is possible to represent the hypothetical surveillance map of that environment for a given instant t, as the third figure shows. This is technically feasible with today's existing tools, and if data on the exact position of all the people leaving the environment at different times and the visual field properties of each of them were available, it would allow to represent the dynamic surveillance map of the environment. This could permit the identification of the more fragile areas in terms of visibility and surveillance, and it could guide interventions aimed at security improvement at different scales and in different areas. For example, mobility planning, requalification and rehabilitation, urban planning and urban design, lighting optimization, and so on. However, a problem emerged. That is, how to collocate in the model agents within the environment in a realistic way without the need of the data. And this is the problem. In some countries or regions or specific areas, such as the airport, for example, it could be possible to have the real-time data, but in other contexts, the privacy issue emerged. This paper tried to overcome the problem by proposing a solution that minimized the data needed in input, still creating a useful decision support tool. Considering... Ok. No. Senza presentazione.
No, soltanto non so perché. Adesso è tornato.
Ok, vai. Considering the general impossibility in tracking the precise agent's movement within the environment, the space syntax comes into play with its ability to interpret the human attitude in terms of flow and movement. In fact, referring to Hilliard's theory, it is possible to interpret the movement and the human behavior within an environment through the analysis of the space itself and establish the flow occurring in the street. So we could conduct, for example, an axial analysis of the environment and consider the integration as a flow measure. So following the axial analysis, it is possible to create a map representing a hypothetical, probable, as supported by the space syntax theory measures, position of people in the environment and their field of view at a given instant t, as represented in the second figure. And this is what we can call hypothetical, probable surveillance map. With this step then, that is the integration of flows measures with ISO-lists, we proceed towards the integration of perceptive and behavioral aspects. That is the key issue in urban environment analysis and space syntax investigations. However, this model still presents two substantial criticalities. The first concerns the distribution of people in the space, quantitatively proportional to the space syntax measures, but randomly positioned, and the orientation of the ISO-lists, which are randomly decided now. In fact, although the number of people could be decided proportionally to the space syntax measure and the visual fields properties can be modeled according to the type of investigation to be performed, the random positioning represents, for sure, a weakness of this model. The second concerns the model's limitations in terms of time variable analysis. So the question is how to solve this problem, and the answer for us is through the integration of ISO-lists and configuration analysis within an agent-based model. In this way, in fact, dynamic maps of agents experiencing the space will be obtained, and then maps of the most or less controlled area with all the meaning that this information could have for us, for urban planners. And in fact, considering the characteristics of the agent-based models, it would be possible to insert additional information to increase the adherence of the model to reality, thus obtaining a realistic simulation of surveillance in public spaces. Many types of information could be included within this model. For example, the social behavior of agents, the land use, the type of activities within the environment, and their working hours or the daytime. That is, in a certain way, a way to add the temporal components within the space syntax theory. Moreover, this tool could be used not only for crime prevention, but also to test in advance the effects on surveillance of hypothetical urban transformations, thus being able to evaluate different alternatives from the visibility point of view. For example, in organizing a city event that temporarily modifies the road network and provides for the installations of temporary structures, it would be possible to evaluate different options from multiple perspectives. The impact from the visual point of view, the areas that would be most affected by weak surveillance, the dynamics that could be generated in terms of flows, in addition, obviously, to all the evaluation that space syntax already allows. And again, as a decision support tool for urban planners, it could allow assessments of the establishment of new activities, their location, and the visual impact that they might have. Furthermore, and this aspect is truly crucial, this model would be, at least in its basic formulation, independent of the availability of sensitive and aggregated input data that could undermine its effective use, particularly in certain contexts. So, arriving to the conclusions, this paper presented the very preliminary results of the elaboration of a digital city surveillance model obtained from the integration of ISOVIST and space syntax concepts, with a further development consisting of the realization of a surveillance-oriented agent-based model. The potentialities of the model have emerged both from the theoretical and operative perspective, and namely in fueling the theoretical debate, realizing surveillance maps that include the temporal component, and correlating perceptive and behavioral aspects. Then the model shows a strong adaptability in terms of sensitive input data, and in particular, it could become a fundamental urban planning decision support system in evaluating alternatives or defining urban intervention priorities. As discussed in the core of the paper, further investigations are required to develop this model. So first, it's necessary to deeply explore the space syntax measures and refine their interpretations in terms of inhabitants' characterization, behavior, and movement, which directly affect the ISOVIST dynamics, and consequently, the visual field properties. Second, the validity of the methodology has to be confirmed with the elaboration of case studies and through the critical comparison with alternative methodological steps, which can include, for example, visibility graph analysis. And third, a technical investigation on how to integrate movement and visual components into an agent-based model is required. So, thank you all for your attention, and if you have questions, I'm very pleased to.
Thank you, Federico. Is there any question from this room? From anybody here? Or is there any question from the web outside this room? There is no question, and so I'm just a little thing I will ask you to highlight, Federico. I would be so kind as to underline which kind of information this model would be expected to provide in order to support decision making.
Okay. Yes. As I've said, it could be useful both from crime fighting and for as a decision support tool for municipalities, for example, or institutions, by highlighting where the surveillance, where the visibility is a problem. I mean, if we could have, for example, for this environment we are living, so these buildings and the spaces between them, or at another level, considering a city, and have the map of the most or less surveyed areas, it could really provide a useful information to have decisions where to improve. For example, lightning, where to improve, where to have urban requalification, or where to, how to say, prioritize interventions within the city. So this is the topic, the main topic of this model, the main issue.
Thank you, Federico. Okay. Thank you, Federico. And now the last presentation is to be. Oh, thank you. You're welcome. Thank you very much. The last presentation is to be made by Diego Altafini, who is already here, and the title is Territorial Disparities in Tuscany, a method to specialize economic data in urban areas, industrial agglomeration. And so, Diego, you have...
Ok. Come metteva la cosina?
Yeah.
Okay. Well, hello to our colleagues. It's a pleasure to be once again at ICCSA. Today I'll present you a methodological paper where we discuss some approaches to territorialize economic data in urban areas. But this focus of this proof of concept is in industrial agglomerations. But I am sure by the end of the presentation you will be able to see uses for other functions. First, let's do a quick overview based on this question. Have in mind the question. Do space and scale matter for economic data? Well, since the initial rationales and locational theories and through the development of them into urban regional economics, space has been regarded as a somewhat intractable notion by economists. Still, from a framework standpoint, it is undeniable that spatial economics, by name, of course, considered space and its organization as important factors for economic dynamism. For them, space matters. In this aspect, it would be very hard to find a regional economics or a new economic geography study that does not consider space. The problem, however, is that the overall role and level of detail that spatial representation and territorialization have in economic models is recurrently contravenes this assumption that space matters. It is well noticed in contemporary economic-based approaches, being urban regional economics or in economic geography, that space and the territorial endowments that constitute it tend to be interpreted as abstracted and often intangible factors, meaning that the spatial parameters are assumed as important, however, are effectively set in a background, underlying the causes and consequences of economic interactions that are more important, such as, for example, the math. We can say that technical and conceptual issues inherent to analyzing the quality of space led to such abstracted interpretation, as few economic models have an approximation with geography. Therefore, the problem is economic models and economic data are not tailored to address in detail aspects about the territorial organization, while also maintaining a concision in its economic variables and parameters. This is the reason that most economic models are fixed on regionalized data, be that at a country-wide level, at a municipal level, or in the most fortuitous cases, at census scales. The lack of integration with GIS platforms, for example, which are now commonplace on urban regional analysis, it's not often seen in pure economics works, which hinders their approach in spatial analysis. Awareness of these limitations and the issues that pertain to spatial economics and its declination of this discipline into urban and regional planning current approaches or to conduce to the development of novel spatial economic models. Those, however, must be able to address the complex spatial behaviors and interactions that might have influence on territorial disparities within the urban regional settings. Therefore, diminishing the scales towards the urban is important, and this is exactly the problem we are trying to address. As our objectives are, in this case, and based on this overview, are to propose a method to territorialize and spatialize economic variables, integrating them with a spatial unit that is representative of the urbanized areas and that can provide in detail location of the territorial endowments within the space, which then can be used to relate it to those variables to other analysis. Passing to the data sets and methods, let's address a little bit of the methodological component, which is the basis of this paper. Well, to territorialize economic data, we need to create a spatial unit that considers the following parameters. First, the territorial structure of space, or where territorial endowments, the built structures or land uses that we want to relate to the economic variables are located. And second, the ability to aggregate different spaces, different points of space within a contiguous area, a macro area of sorts, while maintaining both a certain degree of differentiation among the structures within the space, the elements we use to create a larger spatial unit, and that allow to differentiate the spatial unit according to its size. For this perspective, we establish an intermediate spatial unit that we call the industrial space, because remember, we are working here with, sorry, I went to the pointer. Okay. With industrial spaces. So this industrial space is created, can be created both from the built structures, as you can see here in black in this image, or from what we call industrial assets, or from land uses, as we did initial iterations on previous papers. Both will arrive on the similar results and will represent the base spatial units. From these industrial spaces that we create by submitting the base spatial unit or the industrial assets to a positive and negative buffer to identify eventual points of contiguity in these maps. And along the land uses and the built structures, and maintain the overall size and form of the base spatial unit, which is the industrial assets. We then categorize the resulting spatial industrial spaces according to their size again, and apply the areas of a variable of area of influence based on the information, based on the size information. Those areas of influence are called as a metric displacement that can be used both to establish correlations, but more importantly, to identify the overall spaces of contiguity within the region. We then categorize the larger spatial units, the macro areas that are created. You can see them in this below image. And these macro areas represent the final spatial unit where economic information can be added to, as they will represent the effective boundaries that the base spatial units, the bit structural events, should have, and an approximation as well of the boundaries of the urban areas. Here, to summarize which are which, because I mean this can be a little bit too much to absorb. We have the definitions to individuate each one of these spatial units and the counts that we are arriving this proof of concept for Tuscany. But industrial assets can be defined very simply. It's a volumetric unit that represents the total area of the industrial building, so the base structure. Industrial spaces can be defined as a spatial unit that describes the contiguous area occupied by groups of industrial assets that are set in proximity or in the same parcels of land. The macro areas then can be considered spatial units that territorialize the industrial assets based on the overall reach of their contiguous industrial spaces and denote the general occupation, distribution, size, and industrialization degree of an urban area, while also indicating the mentioned before internal and external logics. So here we have the regional results for this methodology. Macro areas are conceptualized, as you can see in the image, to establish a visual representation of Tuscany industrial territorial occupation, cohesion, and distribution. it informs the industrialization patterns, the dynamics of placement of the industrial assets across the territory, and more important, it is restricted to areas where built structures and land uses effectively exist. So it provides a template for variables that are regionalized to be diminished into the areas that really matter. For our proof of concept, we experimented and used two economic data sets and incorporated them to these macro areas, which are the industrial and service census and the OMI real estate values. I don't pass. Okay. So, both data sets have different degrees of territorialization, and this is thought to better observe if the logics of territorialization function. The first data sets that you can see here represent the industrial service census and comprise variables for local units or how many businesses are in a certain place, the number of employees, and the average firm size. That is a metric calculated from before items. These metrics at economic level can be related to labor in the region, and it's organized on census areas that, so although it's a small spatial unit, it's still regionalized, as you can see. So here we have a problem regarding scale. Sorry. Here we have a problem regarding scale, and my GIF doesn't work. Okay. No, sorry, it's correct. So this second database represents the average OMI real estate values that are obtained from buy and sell transaction of buildings with an industrial use in the period between 2002 and 2021. Therefore, this is a measure of installed capital. Have this in mind. In this field theory, Robert Lucas proposed that capital and labor, the two variables that we are analyzing, are important economic indicators of firms' overall conditions of operation, size, and internal dynamism, as the amount of installed capital, the buildings and the industrial assets, has influence in the allocation of labor or the number of employees. By nature, those economic variables tend to be rather intangible when the spatial distribution is considered. We can notice in both data distributions that are alternating in this GIF that I put in the image, that while some places seem to have a more accurate representation regarding the urban stance, especially seen in the census areas, others data seems to be more regionalized in the sense you have larger stands of low values that you cannot individuate the differences between them. So you have an inlet problem of scale where certain information seems to be more representative than they are actually in the territorial scale. And this point can be seen that here, even with a good spatialization degree for economic standards, industrial census do not provide a sufficient differentiation or an exact positional information that indicates the differences in distribution. When we join economic variables to the macro area, we restrict the data that is flashing to the areas with effective functional presence and effectively to the urban areas. This results in a more precise overview of the data as it surpasses all the areas where information is actually non-existent, as in the gray areas, or very low in density in terms of presence of built structures. So you can see in the flashing image that the low densities that seem to be very important in the census areas original data set at the regional scale are equivalent to what they are when you cross it with the macro areas distribution. Very low density spaces, very low information is there. Likewise, in the industrial census, the only real estate values territorialization provide a limited spatial differentiation, as data distribution does not provide precise position information that indicates the patterns within in urbanized areas. In the omni values case, this issue is even more significant as territorial divisions have a larger regionalization pattern, as you can see on the area for Siena, for example. While in the industrial service census, these issues can be mitigated with, for example, the addition of the industrial assets data set. So you can see both data sets opposed to each other. It does not solve the issues of territorialization accuracy regarding location, especially on the areas on the outskirts of the urban settlements. In this aspect, joined with the macro area spatial unit greatly improves the territorialization of the data set. And we can see here on the data tables that the amount of reduction caused by the incorporation of macro areas datasets can verify that this reduction is more evident in the very low values, or those values that are not as important territory regarding the overall scheme of the data. The results are similar for the census, as I showed before, where the no data variable is eliminated and the reductions in the areas that have very low density, the densities are very significant in terms of total area displayed. So, to the conclusions and for the research, well, the territorialization of economic variables is an issue that matters for both spatial economics and, of course, very much to urban and regional planning. So, integrated spatial economic analysis at urban and regional scales requires a level of detail in spatialization that is unattainable through the sole usage of traditional regionalized economic variables and traditional spatial representation, such as those representations in the census and the omni-value areas that are already treated to some extent. While this kind of territorialization can be reasonably accurate for certain cases on cities, on large cities mostly, or in urban cores, it tends to greatly lose precision near the city boundaries due to the increment of the survey areas and, of course, the size of the survey areas associated with the decrement of data occurrences. The proof of concept that we made in GIS using data for the Tuscany region demonstrated that the use of a restricted space through the spatial unit based on the build structures or build structures positions, the macro area, can mitigate those spatialization problems of regionalized databases, diminishing the overall imprecisions in local and giving the data we have better defined boundaries for the city centers. And for further research, well, further studies tend to be focused on improving this spatial unit and above all the spatial unit creation methods, trying to adapt it better to functions outside the industrial one, because these tests we made for the industrial function that might have to be submitted to certain adequations for other urban functions. As well, to the other need we have is to test with other economic values, to test if the improvements on visualization are consistent. For now, we did for those two variables. Still, and it's a point to make everyone think, we believe that especially for us in urban regional planning, which is important really, is a shift on how economic data is made available and how economic data is specialized. Given the novel requirements of spatial research, we cannot deal anymore with data at a communal level. We need a deeper, how can I say, a deeper understanding of positioning data, economic data within the city. This means that we need to strive to metadata with localized information, especially at urban scales. And thank you all for the patience, especially. And I'm open to any questions that might arise.
Yeah, thank you. Thank you. Thank you, Diego. And is there any question to Diego? Oh, yeah, Cara, you're welcome.
Yeah, but just a suggestion. First of all, congratulations for your wonderful work, also because generally I work in a municipality level, city level, so in the regional level I can understand that there is a lot of work. My suggestion is you spoke about economic value, why do you not think to try to put together also other indexes or other elements in order to understand also the vitality of the different the different part of the region territory. I can understand that working in a regional level, it's bigger than another kind of spatial analysis, but could be a suggestion. Okay.
No, Chiara, thank you for your suggestion, for your question. Yes, indeed, it is could be an interesting development, but I am more concerned about how we measure it, because just to be clear, economic variables, how can I say, are very easy to incorporate because we know how they measure, we know the specialization. We could try to take the vitality index and, how can I say, join this to the macro areas, but we need first a regionalized logic, because if we do from, how can I say, from more larger, it could be a problem, because even with this kind of specialization, you might not see the differences within a local level. It could be tested. It could be tested.
Try it together.
No, yes, you can test it, because it's a very interesting proposition.
Very interesting. Okay, yeah. Any other question? From the web, from those who are remotely connected? I don't know. I think it's this one. I don't know where to look at. No, I don't see. No. Any question? Just to conclude, Diego, could you please specify which applications do you foster for these methods? I would ask you to be short.
Okay, I'll be very short. Well, the main application is of these methods, since we deal with very localized data, is to analyze territorial disparities at the regional level. It's the main and foremost usage of these logics of macro areas. For now, it will be the most, how can I say, the most palpable development.
I thank you. Thank you very much, Diego. Thanks to Veronica, thanks to Alfonso, Chiara, and thanks to Federico, Diego, and thanks to everybody participating here and there somewhere. And
it can all I think session. Yes. Thank you very much. See you tomorrow.